Okay, illustrative math, Algebra 2, Unit 2, Lesson 6 is called different forms, particularly different forms of polynomials. All right, our goals today. I understand that polynomials can be written in standard form and factored form. I can describe features of polynomial graphs and expressions using precise language, and I can identify properties of polynomials by representing them in equivalent forms. So we're going to go to the warm-up. Which one doesn't belong? Try to come up with a reason for everyone if possible. And I'll write them right over here to the right. So for A, we could say this is the only polynomial in factored form, or we could say not in standard form. Now I could put that into standard form if I wanted to. If I wanted to make a box, let's see here. I want to make a box and multiply that out. I'll put the x plus 4 on one side, and I'd put the x minus 6 on the other side. So I'll put x and 4, x and negative 6, and when I multiply these, I get x squared. These are 4x. This is negative 6x, and this is negative 24. Now the 4x and the negative 6x, you can combine those because those are like terms. So this polynomial, if I wanted to move it into standard form, when I combine those two like terms, all right, when I combine the 4x and the negative 6x, I get the negative 2x right here. I could put it into standard form, but anyways, that would be the reason for that one. All right, if I go right here, this is the only polynomial with coefficient other than 1. Okay, because you look here and you got that 2 right there in front of the x squared. Okay. So if I look at the third one, when you look at that 25 there at the end, this is the only polynomial with a constant other than 24, or negative 24, I should say. Okay, so if you look at this one, well, let me use a different color. If I look at this, D has a constant negative 24, B is a constant negative 24, and A, although it's hidden, if you multiply the constant times the constant, we get the negative 24. You don't even need to FOIL the whole thing out or multiply the whole thing out. You could do 4 times negative 6, just constant times constant. That'll give you the constant term. So when you look here at this one here, this negative 25 is a different constant. And then the last one, this is the only polynomial with a degree other than 2. So the highest power is 3 on this one. So, whoops. So if you look at the degree here, the highest power is 3. You could also say it's the only one with 4 terms, because when you look here, you got 4 terms there. So you could say, oops. Say only polynomial with 4 terms. The other ones all have 3 terms, okay? All right, so return of the box. Earlier we learned that we can make a box from a piece of paper by cutting squares of side length x from each corner and then folding up the sides. Let's say we now have a piece of paper that's 8.5 by 14 inches. The volume V in cubic inches of the box is a function of the side length x, where V of x equals 14 minus 2x, 8.5 minus 2x times x. So just to make sure we remember this, I'm going to draw a little picture here. So if this is my piece of paper, you're basically going to cut these little squares out of every corner. So you're basically cutting these out. And I'll show you here what's going to happen. So basically this side here, the whole thing is 8.5. And this is 14 from here to here. So this side here, you're gonna basically fold this box up right. Make a dotted line here. It's supposed to be dotted, but I'll just draw it here. So this is going to be your box. I'll highlight it. This is the base of your box. And these flaps right here get folded up. So fold up, fold up, fold up. And same thing here, this gets folded up. These get thrown out. Okay, so I'm just going to X them out. Okay, so this side here of your box, this is 8.5 minus 2x. Okay, so 8.5 minus 2x. This side here is 14 minus 2x. And then your flaps have a height of x because every box here was really, and it kind of looks like I meant to do this, but I didn't. These are really x by x. So maybe if I get rid of these x's here, think of these little squares as getting thrown out, but each one of these squares is x by x. So when I fold that up, the box has a height of x. All right, so anyways, back to this here. Identify the degree and leading term of the polynomial. So it's in factored form, so we can't figure out the degree until we multiply it all out. So you could do this a couple different ways. You could multiply the x into here and then make a box and multiply whatever you get from that times 14 minus 2x. Or the little shortcut is to just take the highest term in each parenthesis, in each factor. So if I multiplied negative 2x times negative 2x times x, that's the highest power in this parenthesis. This is the highest power on your variable, I should say, in this parenthesis. And then that's obviously the only term there. So let's do this. Instead of doing the shortcut, I'm going to start out by just multiplying it out. So 14 minus 2x. What I'm going to do is I'm going to take this x into here. So I'm going to make this 8.5x minus 2x squared. And then I'm going to multiply these, and I'm going to draw a box to do that again. So this is going to be, and it doesn't matter which side you put each parenthesis on your box. And you're just multiplying. So here we go, 8.5x times 14. So that gives you 119x. This here gives me negative 28x squared. This gives me negative 17x. And this would give me positive 4x cubed. So if I rewrite this all out, I get 4x cubed. You can combine these two because, no, you can't. I'm sorry, I forgot my squared here. There we go. Now you can combine those two because they're like terms. So that should be negative 45x squared and then plus 119x. So that whole polynomial v of x gets multiplied into that. So obviously your degree is 3 and the lead coefficient's 4. So degree 3. Okay, so there's your answer to that. Whoops. Let me try that again. All right, so the shortcut would have been just multiplying the negative 2x times negative 2x times the x. So let's just do it here. Negative 2x times negative 2x times x. If I multiply all that, I get the positive 4x cubed. So it gives me that first term like I wanted. So you take the highest power on your variable in each parenthesis to multiply it all together. So I don't really need this to answer this question. So without graphing, what can you say about the horizontal and vertical intercepts of the graph of f? Do these points make sense? So your horizontal intercepts, you set each factor equal to 0. So 14 minus 2x equals 0. 8.5 minus 2x equals 0. And x equals 0. This one's nice. I don't have to do any algebra. This one, I move the 2x over. Divide each side by 2. Same thing here. Add 2x to both sides. Divide by 2. 4.25. The vertical intercept is the constant, so I don't really have a constant here. It's really plus 0. So my y-intercept equals 0. Okay, and that makes sense. If my x-intercept 0, you're going through, if this is my y-axis, this is my x-axis. If the x is 0, y is also 0 too, because it's going through the origin. So let's think here. Do they make sense in this situation? So remember, what's x? X is the side length of your square that you're cutting out, okay? So can x equal 0? Well, if I cut out a square with side length of 0, it doesn't really work. You won't have anything to fold up. So this one does not make sense, okay? Now, the same thing here with this one, 7. I only have 8.5 inches here on this side. So if I cut a square of 7 over here, and I cut a square of 7 over here, that's 7 and 7's 14. I wouldn't have any side left here to fold up. So this doesn't make any sense. So the only one that makes sense is the 4.25. Now I would have just enough left because if I go 4.25 on the right, 4.25 on the left, think about this here, 4.25 over here for your square, 4.25 over here for your square. In the middle, you have, no, wait, actually that wouldn't work either because they're at 8.5. So I don't think any of these would make any sense. Okay, so in the terms of this problem, actually that wouldn't work because if you add that up, that's 8.5 and that's the whole side. So yeah, none of these make any sense. So my answer would be, I would just say none of these make sense because x would need to be between 0 and 4.25, not including 0 and 4.25. That way you have enough box left to fold up. Okay, so use the distributive property to show that each pair of expressions is equivalent. So I've kind of already been doing that. So I like to use the box method. I think it's nice to stay organized. So I can just multiply here. Actually, let me move this over here. I'll tell you what, I'll just copy all of these right now. And I'm going to make this one a little bit bigger. Because I need to have 3 terms on one of those. All right. All right, so I got x and 2, x and 4, and I'm not going to draw the lines in here. I'm just going to multiply them here. X squared, 2x, 4x, and 8. So these are like terms, so when I combine them, I get x squared plus 6x, add the coefficients, plus 8. Equal to that? Yes. Good. X and 6. So x plus negative 5. I don't really like how that's written. I'd probably write it like that, just so you know. All right, x times x is x squared. Add the powers. 6 times x is 6x. Negative 5 times x is negative 5x. Negative 5 times 6 is negative 30. Again, these are like terms, so I add those two together. So 6 minus 5 is 1. So I don't need to put the 1 in front of it. We know if it's just x, it's 1x. And check if that matches, which it does. Now this is a trinomial times a binomial. Doesn't change the process, just changes how much work we have. Multiply these. And then look for like terms. So these are like terms, and so are these, the x's and then the x squareds. I always like to write them in standard form, so my powers are going down. Negative 1 plus 20 is 19. Negative 10 plus 14 is 4. And there you go. And as a matchup, looks good. Okay. Oh, I got one more. So this is still binomial times binomial. So it's just going to be a little different because this is x squared and this is x cubed. The one we did earlier, both of these were x to the first. So these were linear factors is how we would call that. This is squared. We call that a quadratic factor. And this is cubed. We call that a cubic factor. So anyways, we go here. We get 4x to the 5th. We get 12x cubed. These are negative 24. Now, it's really easy to just get in the habit of adding them diagonally, but when you look here, they have different powers on everything. So don't combine terms that are not like terms. Really, there's nothing to combine. And we end up with that, and that checks out with that. Okay. All right, write in a pair of expressions that have 2 or 3 terms and trade them with your partner, multiply the expressions they gave you. So write a pair of expressions that have 2 or 3 terms. Okay, so a pair of expressions that have 2 or 3 terms. So 2x cubed plus 2x plus 1. There's mine. And then here's another one. 4x squared minus 1. Okay, so here's mine, and here's my partner's. So I'm going to multiply these. So really, I'm just going to do this. I'm going to put parentheses here, and then I'm going to make a box. It doesn't matter where they go. I'll put the trinomial on the top because I made my rectangle a little bit wider that way. So start looking for like terms. Let me double check all my math here. So these are the only like terms that I have. So if I combine everything, I get 8x to the fifth. When I combine these, I get 6x cubed. And then I get 4x squared minus 2x. Don't accidentally combine those. Minus 1. So there is your answer. Okay. All right. So use the applet. I'm just going to say use a graphing calculator here to explore both functions in the same window. Negative 10 to 10 for x, negative 100 to 100 for y. Describe how the two graphs are the same and how they are different. So I have them both graphed here. The red one is f of x, and the blue one is g of x. So how are they the same? How are they, and look at my window here. I set my y's from negative 100 to 100. X is negative 10 to 10, just like it said. So how are they the same? I would say they're the same. If you look at the x-intercepts, they're all the same. And if you look at the factors here, I got x minus 2, x plus 3, and x minus 7. So I would say same factors. Same factors, same x-intercepts. How are they different? I would say your y-intercepts are different, and your local max and your local mins are different, okay? So y-intercepts are different, and your local or relative maximum and minimum are different, okay? So if you look here, this max and that max, relative max, are different. This relative minimum and that relative minimum are different, and so are the y-intercepts, okay? So what we have there, and on the graph here, we also have, on the function, we have this 1/2 right there, if you look at that. So g of x has a coefficient constant of 1/2. Okay, so I'm thinking what happens here, and you're probably thinking the same thing, is this 1/2 affects the height of the red, or I guess the 1/2, that's the blue one. It affects the height of the blue curve. It kind of smashes it down if you see that there. Okay, so what degree do these polynomials have? Rewrite them in standard form to check. So what degree? So I guess I got to rewrite them both in standard form. So the first one, x minus 2 times x plus 3 times x minus 7. So we could do two boxes. What we could do is put these two together, or the first two, and when I make my box, I get x squared, 3x, negative 7x, negative 21. So this is going to become x squared minus 4x minus 21. And then I could do another box here, x squared, negative 4x, negative 21. So I starting to, instead of drawing the box out, I just write it like that. X cubed, negative 4x squared. So you're just multiplying everything. So multiply it all out and then combine all your like terms. We get x cubed minus 6x squared minus 13x plus 42. So that was, I believe that was f of x. Yes. Okay. So the other one, the g of x, everything's the same. The only difference is you have that 1/2 there. So at the end, you're going to have to multiply everything by 1/2. So it'd be 1/2 x cubed minus 3x squared minus 13 over 2x plus 21. You're basically doing one more distributing. You're distributing a 1/2 to all of these. So what degree do these polynomials have? Obviously, the highest power is 3 for both of these. If you look right there, 3, 3. So the degree is 3. And there's my standard form. Okay. And now that makes sense because the constant tells you the y-intercept. So 42 and 21, you can see that the f of x has a y-intercept up here like 42. The blue one's at 21. All right, here's another one. So I'm going to write the f of x here. So f of x was, let me go back, x minus 2 times x plus 3 times x minus 7. So how do you think it'll look? So this here, it's almost the same thing as the last one, but this one here, it's almost like you took the 3 and distributed into an x minus 2. If I did 3 times x, 3 times negative 2, I'd get this exact same term. So maybe rewrite this as 3 times x minus 2, x plus 3, x minus 7. And now they look exactly the same. So the h of x has a 3 there. So I would say that the h of x function will go 3 times higher. Because it has that extra 3 in the front. Now, because these factors all match up, x minus 2, x minus 2, x plus 3, x plus 3, x minus 7, x minus 7, so those all match up, I think they're going to have the same y-intercept or x-intercepts. Same x-intercepts or horizontal intercepts. So let's take a look at our graph and see what happens here. And sure enough, the blue one is h of x, and h is 3 times higher. If you look, 1, 2, 3 times higher. Same x-intercepts, we got 7, 2, and negative 3. That's by setting each one of these factors equal to 0. So I set x minus 7 equal to 0 and solve it. I get x equals 7. X plus 3 equals 0. Set that equals 0. You solve that, you get negative 3. And then same thing here, you get a positive 2. All right, so here's two functions here. Actually, they're the same function because they're both f of x. So where can you see the 240 in the factored form of the equation? So standard form, 240 is the constant. So in order to find 240, you got to multiply all your constants together. So 4 times negative 6 times negative 10. And see if that gives me the 240. Okay. Which is, well, negative 2. Well, wait. Oh, it's a negative 10. I knew something was wrong because it should have been a positive 240. So I would say here I multiply the constants. Okay, so there we go. So that equals 240. And then on the graph, the 240 is the y-intercept. Okay, so the constant is always the y-intercept. All right, which form do you think is better? Well, here's what I would say. I would say factored form is better to find x-intercepts. Standard form is better to find the y-intercept. All right, last question. Let's say g of x is a polynomial with the same zeros and degree with a vertical intercept of 120 instead of 240. What could the equation of g of x be? So this one, your y-intercept is going to get squished down halfway. So everything's the same as far as your factors go. You're going to keep x plus 4, 2x minus 6, x minus 10, and you're going to just multiply everything by 1/2. Okay, or if I wanted to use the other form, since they're the same equation, you could take 1/2 times this whole thing. If you even want to get fancy, you could distribute that and make that x cubed minus 9x squared minus 22x plus 120. Now you can really see that the y-intercept is 120 there because your constant is equal to 120. All right, learning goal. I understand that polynomials can be written in standard form and factored form. I can describe features of polynomial graphs and expressions using precise language. And I can identify properties of polynomials by representing them in equivalent forms. Now, I will say for this last one, we went from factored form to standard. Okay, we did not go from standard to factor. This will be later. Okay, this was now. So that goal is a little deceiving. We can't go this way yet. All right, last thing, cool down. So rewrite this polynomial in standard form. So let's do this. Group any of them together. I'll do the first two. Multiply your box. Combine like terms. So really I have x squared plus 9x plus 18 times x minus 5. And then I'm going to do another box. What's that, negative 90, I think. Okay, so combine your like terms, x cubed, 4x squared. Again, remember where the 4x squared comes from. It comes from adding those and then combine those. I get, what's that, negative 27, I think. And then this was equal to p of x. So I want to keep it the same. The degree and the constant. So your degree is 3. Your constant is negative 90. And just a little bonus here, your x-intercepts are negative 6 from there, negative 3 from there, and positive 5. My y-intercept is the constant, so that would be negative 90. Okay, hope you enjoyed this video.